We just learned that by using console messages to perform error handling is not appropriate because we can easily end up having contradictory messages printed out to the console. It really boils down into when the error actually occurred, console messages would not actually interrupt the current execution flow and actually force the caller to actually handle the error, or some caller along the call chain to handle the error. So what we want to do as a proper solution is to use something called exceptions. You can think about exceptions are simply some special objects which we can create when the error occurs, and also throw those objects to the runtime system, and the runtime system will enforce for us automatically that some caller along the call chain must handle that error objects. So that would be the way to go, rather than just console messages. All right, so let's now introduce to you the idea about an exception, and then I'll go over some principle of handling the exception. And the idea about call stack will be very important, because typically exception might happen when there are already several method calls in your call stack, and typically it will happen at the top of the call stack. And now you have to worry about which caller actually along the call stack will actually be able to handle the error. So that'll be something to actually worry about. But I will actually visualize what's happening when I go over the example. You got actually many possibilities to really consider in terms of exception handling. Okay, let's now introduce the notion about exception. What is an exception? You can think about exception is more like abnormal events that can happen throughout the course of the execution of your system, which occurs during the execution of a program. So it's really during the runtime. So exception is really a runtime phenomenon, and it will disrupt the normal flow of the progress instruction. So the second bullet point over here is extremely important. This really distinguishes exceptions from console messages. In the case of console messages, the execution flow will go as normal without being disrupted. But in the case of exception, it will be handled automatically by the runtime system. So that's why we are using exception instead, right? So these two bullet points are really important for you to note. When an error occurs within a method, let's say, for example, right, we talked about two errors in the earlier example. Let me revisit them very quickly. In the case of the circles example, errors might occur when the radius is actually strictly less than 0. That's when the error occurs. So we want to say, rather than printing out an error to say invalid radius to the console, we want to throw some exception objects instead, right? That's for one example. In the case of the bank, similarly, let's say we talk about a withdrawal method, and it will be considered an error if either the amount to withdraw is too small, is strictly less than 0, or the amount is actually way too large, which will cause your balance to go below 0. In that case, instead of just printing out some error message to the console, we want to throw some exception object instead to the runtime system. So these are the two timings where we may want to actually throw an exception. One more thing to say. You can see when the error actually occurred in this particular place, that means we are now in this particular the top of this call stack over here, because we're calling circle.setRadius over here, and then we found that radius that's being passed as input is actually strictly less than 0. So now this will be the place, the top of the call stack, where the exception will occur. Similarly, we can see when we actually want to throw some exception objects because of some error on the withdrawal amount, we are now also on the top of the stack when the context is account.withdraw, right? Exactly this method here. So that's why I said usually when the almost always when the exception occurs, you will be on the top of your stack, the method that's being active. And as soon as the exception occurred, the stack will not be accumulated to be more method call anymore. Instead, we're going to disrupt the execution flow and then try to search for some methods along the call stack and to find out which one can actually handle the exception. So that'll be the conceptual idea you want to have in your mind. All right, so let me now go back to the slides. So the method throws an exception either from setRadius or maybe from withdraw, right? And first, it's going to create some exception objects. And to create the exception object, you will just say use the new keyword. So the principle follows like what we did in the review series. and then it's going to hand over to the runtime system. And there is a special keyword we have to use to signal that we want to hand this newly created exception object to the runtime system. The keyword will be throws with S, throws. You will see that when I do the example together with you. And the exception object contains the information about the error. Okay, so it's an object, so it might contain some internal attributes which will record the states of the error states of the system. It will be the type of the exception, and also, for example, it could be negative radius exception. So that's about the type, the kind of error that you have, and also the state of the program when the error occurred. So these are the two main things, right? We'll show you some common usage of inquiring the states of the exception objects, but you can definitely explore further by going to the exception objects in the Java API library. We can go there as well. Okay. All right. So what should we do when an exception is thrown? Let me now go over the slides point by point, and I'll do some visual illustration to you as well, just to show to you. But before I go over the principle, let me show you the one I want to do some visual illustration. Let's imagine that this is more like a general method call situation. So you have a call chain. Imagine that this is the stack. Okay, let me just say over here. You can imagine that, right? That's how I draw the stack, right? So this will be the stack, like that. This will be the stack. And apparently this method over here will be the top of the stack. So we have some top, and also we got the bottom over here. And for simplicity, let's assume we only got 4 methods in the call chain. In reality, there might be fewer, there might be more, right? So the same principle will just follow. And let's say we got the top of the stack over here, and also we got the bottom of the stack. And let's say we talk about console application. So the main method, as I said, is going to be put in a reverse chronological order. Main method will be the entry point of execution. That's why it will be first put into the stack, and eventually it will become the bottom of the stack. And this method here was the latest one that's being called, and this might be the one that will run into error, in which case we will when the error occurred, and we will actually throw some exception objects from the top of the stack. So that's kind of the context I'm talking about. Okay, and then here in the middle over here, I talk about 2 methods over here just for example. So one is the method without an exception handler. I'll speak about what exception handler really is later in the video to show you, but you can think about exception handler really means we have a try and catch block, and I'll show you the syntax of that in the later video. So let's say the immediately below method over here, you can think about the caller of the method that generates the error does not have an exception handler, and the further caller over here does have the exception handler. Right? So as soon as we actually can find the exception handler along the call stack, that means the error will be handled at this point specifically, and that it will not be propagated further. So that's kind of the visual intuition you want to have about the call stack. Okay. Let me now go back to the slides and then go over point by point, and I might refer to this diagram again. Okay, let's see. After a method throws an exception, the runtime system searches the corresponding call stack for a method that contains a block of code to handle the exception, right? So what we are saying is, let's say this is the method that actually throws the exception. So let me put the notes over here. So this is where the error occurs and exception object thrown. Exception object thrown. So this is exactly where it happened. And typically in this method over here, you do not handle the error, the exception right away. You will propagate that to your caller, right? You can see the caller of this is the callee, and this is the caller, right? You can think about in the case of call stack, always it's kind of relative. If you consider these 2 methods over here, the top one will be the caller. The top one will be the callee, and the bottom one over here will be the caller. Similarly, this will be the callee, and this will be the caller. And this will be the callee, this will be the caller, and etc. Okay. Let's see what else. And this block of code is called an exception handler. And exception handler is really referring to try and catch block, which I will explain. I'll show you some example in this video, but I will try to program that as well in Eclipse in the next video. An exception handler is appropriate if the type of the exception object thrown matches the type that can be handled by the handler. Basically, when you want to try and catch, the catch part must specify the kind of exception you want to catch, and that type must match the exception that's being thrown from the method that originates the error. Okay. The exception handler chosen is set to catch the exception. That's why we gotta try and catch block. Try and catch are another new keywords you have to learn in Java. The search goes from the top to the bottom of the call stack. So once this error, actually an exception object have occurred at the runtime, we have to search along the way to the call stack to search for the first one that will actually got the exception handler. Okay, so let me make a note over here. So you can think about, we're going to search in this way. Okay, let me just go a little bit thicker. So we're going to search in this way, right? So this is the direction to search from top to bottom. In which case we're going to search for the first caller method with exception handler. I'll just say EH, but what I meant was exception handler, and this will be the first one. Okay, so this is the first caller with exception handler, meaning that at this point we're going to handle the exception. Okay, so this is where we actually handle the exception, and again notice that this is where the exception object was thrown, and we'll forward the exception to its caller. However, this caller over here does not have the exception handler. Let's say that's for the example. And then, so that's why we have to propagate further to its caller further. And then this one actually got the exception handler, so that's why the exception will be handled exactly over here. In that case, we don't have to propagate the exception any further because it has been handled. Okay. And then let me just say one more note, and then I'll go back to the slides. Okay, so I would say since the exception is handled here, it will not be propagated further. Will not be forwarded further or propagated further. Okay, so that is why you can see the error over here. It will be propagated to this one, but it will just go to itself, meaning that it has been done already. So there's no arrow actually to propagate the exception from here to here. So I'm just helping you understand this particular diagram. Okay, let's go back. And then the method in which the error occurs is search first. So we start from searching this method, right? That's the originated method for the error. And then we'll go back here. The exception handler is not found in the current method being searched. In that case, we'll search a method that calls the current method, which means its caller. For example, the exception handler usually would not be in this in the method that originates the error itself. So that's why we have to search for its caller. And this one here does not have the exception handler, so that's why we're going to search for the next one. And this one does have the exception handler, so that means we're going to handle that and we do not propagate it further. Right? I'm just trying to keep repeating the points, so hopefully at least we get an intuition. So when you see me programming exceptions in the next video, you can more easily follow. Okay, when an appropriate handler is found, the runtime system passes the exception to the handler, right? So that will be exactly here, as I said. Okay, and then the runtime system searches all the methods on the call stack without finding an appropriate exception handler. So this is the worst case, right? Let's say hypothetically, if also this method here also is without the exception handler, that means the exception will be propagated further to the main method. So this is the entry point of execution. And presumably, this main method should have the exception handler. But in the worst case, it is also possible it does not have the try and catch block, the exception handler. In which case, the exception will just be propagated further to the furthest possible. In that case, the exception will just be thrown to the console. So this is really the worst scenario because you're throwing the objects to the console, which the user will see. The user should not be bothered by such an exception, but it's just the worst case, which I'll illustrate to you as well later. Okay, so the program terminates and the exception object is directly thrown to the console. This is possible, but you really want to avoid, right? It's not a good practice. All right, so that's a diagram I just illustrated. So you can go over that. So this is a clean version, and this is an annotated version. You can look at both. Okay.